Recording started.
Okay. Okay, can everyone hear me okay? I guess if you couldn't hear me, you couldn't respond, so yeah. Okay, so let's start by going into now. Oh, yep. So these are the files from last time, and what I'll do is I'll open up the tutorial sheet. Just give me a sec. And in course documents, and we're in week 9. Amazing. So basically what we're doing today is we're continuing from where we were at with our list last week, and now what we want to be able to do is to delete a person from our list. So once again, I'm going to ask the usual question: how many of you have had a chance to look at the lecture material for week 9? Yeah, good. That's a bit better. It's really important. I have been releasing the lectures 2 weeks before the tutorial. So for example, today I uploaded the material for week 11. So you can always, you've got 2 weeks between when I upload it to actually have a look. I do realise people are busy, I'm busy too, but it really is important. It makes a difference in terms of how much you remember coming out of these sessions, how useful your input can be to the session, because you'll have had some of a look, and you won't help but have to think a little bit about the material, because everything you see and so on, you think about a little bit no matter what, right? So yeah, anyway, so what we're going to do, we're now going to implement a delete for our list. So let's go to our list. Okay, so let's have a look in list.h and list.c, and I'll open them in sub windows like so. Where the top window is the header file, and the bottom window is our the C file. Okay, so last week we would have specified, here we go, list remove. So we decided the ID was going to be an int, and so let's just have a look up here in the structure. So we've got the data, which is a person. Let's just have a look, person.h, where we've got first name, last name, age, ID. To be honest, I've been thinking about this one a bit. It kind of doesn't make sense for an ID to be an int. Can you think of why? Why would we not actually use an int for our ID? What's the problem? Well, actually, chars are more expensive. But I think in the case of an ID, the cost is kind of worth it. Because, you remember, each char takes up 8 bytes, or 8 bits. Each char takes up 8 bits. And therefore, for a number, say a number, the number 1000, as a string is 4 bytes, right? Well, does it make sense to be subtracting IDs or multiplying IDs by each other? Or so in essence, it's an identification string, yeah? So I'm not going to actually change it here, but I did want to raise that as an issue. That in fact, in the real world, you probably shouldn't be using an int for an ID, just like you wouldn't use an int for a phone number, right? Use a string. So an array of char. Yeah. But we'll leave it as it is because we want to get on to the issue of lists. Oh, what I might do before we jump into here is I want to actually show you something. I'm surprised no one has asked yet when the assignment results will be coming out. Is that because people aren't interested, or because normally this is the 2-week anniversary, right? Okay, unfortunately they'll probably be delayed for another week. Basically, I want to mark them all, and I'm about halfway through. So I reckon I can get them done over the next weekend, but I don't have a lot of time before that to do it. So sorry about that, but I can give you some feedback. Because I have okay, I won't. So if we're looking in here at the marking, and I'll jump immediately to sheet 2. So currently that's the mean mark. I've marked about half of you, that's the mean mark. And what I will do is I'll pull out a few other stats for you. The max, now hang on, what was the, I can just copy that and I'll grab the max. "97 is the maximum anyone got out of 100. But someone got 18 out of 100. Yep, so count if so currently I've marked about 20 of you, and this is how many HDs. 7 out of 20 people have got a high distinction. And 6 have failed. So that means that there is another 13 who passed and didn't get a HD. So basically there's 14 passes, 6 fails so far out of the 20 I've marked. Now, there are about 43 submissions, but there's about 60 people in the course. Normally about 1/3 of you never submit anything. That's normal. No, not really, because what it means, and let's draw this out, equals, I'll do this very quickly, so greater than or equal to 70 minus oops. So that's distinctions. One credit. Well, you can tell from the assignment spec what, if you just add up the bits, which you did. The bottom line, hang on, let's finish this. file. Stupid piece of rubbish software. So 15 passes so far out of 20. That's pretty good. And you have already got your, oh yeah. What, do you expect everyone to pass? Considering some people, I would say, basically displayed the board and quit. Like a lot of people did very little work. I'm sorry, I have to say that. And so, this is normal. Well, I would say that there were slightly more fails than what I had over summer. Like that people had not planned to actually do the work, or were surprised by the amount of work. Substantial numbers of people that I feel that was the case. Well, you know, given that 75% of those who submitted passed, that's good. Yeah. So the message here is that you should be heavily into you should be heavily into your assignment 2 submissions. Well, particularly after tonight, you will have gotten the material you need. Most of it. No, all of it, because I've given you the conditional compilation stuff, so you don't have to write anything for that. But the materials you need for the assignment will be delivered after tonight's session. So you should be really getting heavily into the assignment at this point. Okay? But just thought I'd give you that feedback that basically the results range from 97 to 18. And actually I'm happy that it only went that low, but we'll see. Now there's no hurdles, but it means that I feel freer to make the exam slightly more difficult than what it was when there were hurdles. So the absence of hurdles doesn't necessarily mean, yeah. But anyway, look, you have had access to a sample solution now for a week, or almost a week. So you can use that to review. And I should be getting lots of questions at this point. I'm not. So you should be firing them at me. So anyway, this is motivation. Don't forget we have the session on Wednesday at 7:30, where I will walk through the assignment with you. And you have your opportunity to ask me any questions, etc., etc. at that point. Okay? Alrighty. So that's that. Alrighty. So now let's get back to our code. Okay, so deletion is the same no matter what the data structure, or the steps are the same. Right? So let's go through what those steps are. Search. So firstly, we need to search for the item to delete. Yep. Then we need to remove the item from the list. And free memory. Well, depending on the data structures you're using, maybe you don't need to free memory. Well, that might depend. But that's essentially what all Why do you think that I'm emphasizing that all lists involve this in the context of your assignment? Well, you've got to deal with two kinds of lists, right? So it means that there are some things that you're going to do in common. Yeah. Alrighty. Now remember what I've said before about these default return values? You should be removing them. They're just there to avoid a compiler warning, right? So you should be removing them. I shouldn't see an implementation of your function which has a dead return false at the end, because that basically, I follow a convention that if a function has not been implemented, it should return false. It should always fail. So that's what I'm doing there. Okay, so what do I need to do? First off, what is the easiest thing to do when considering deletion from a list? What is the list which will always fail for a removal? An empty one. Correct. So if, and we refer back to our specification up the top, if list, oh look at that, this is an idea I got from Shane, who was asking about whether you could actually have some kind of code completion in Vim. This is a little thing I installed, which actually gives me code completion, right? Which is kind of nice. So if list num node 0, well, printf standard error, you should be printing out all error messages to standard error. Have a look at the there's a discussion post from Shane, and if you just follow that link, there's A library, basically what it does is it uses Clang, which is another C compiler, to actually get information about the types that you're using. Vim is actually incredibly powerful, actually, but anyway. Okay. Unfortunately, we don't get the whole shebang with like control space like you do in some other systems, but anyway. So okay, so just close that because that's a little bit annoying. Okay, so now what should we do next? We've verified that the list is not empty. Search the list. So do we need some variables to help us in our search over a linked list? Well, we don't know because, see, a linked list we can't index into. Yep. Well, we don't know how many. It is a mistake that new programmers using linked structures do, is try to use them like an array. They are more like an iterable data structure. That is, we can iterate over it. So yeah, what I'll do is I'll create two struct node pointers. So current next. Now is that a let's call it previous actually. Now I've made some mistake there. What have I done? Two mistakes actually. Correct. The pointer at the front here only applies to the element next to it. So previous needs to be null. Correct. Because otherwise we don't have an initial value for prev. We should always assign before. It's the idea that we should write to something before we read from it. And that's where Valgrind has some messages, you know, invalid read, invalid write. And that's what they're about. That when you read, well, in that case, it's actually reading from memory you don't have a right, you shouldn't even have access to. But the conditional based on uninitialized values, which I'm sure people saw in their debugging assignment, that's more about reading from something that hasn't been written to. Okay? So, alrighty, what do I do now? I've got some pointers. Give me some pointers on how to use these pointers. Haha. My priority is on assignment 1 first. So I would say the following week. The week after you get your results from assignment 1. Because it will take a lot less time to mark them. Yep. So what am I going to do here? Well, I've got to do something with these pointers. Well, that's what you need to be. The data is a member of the node. So we need to find the node first. We need to iterate over the node. So current equals list head. While. So how do we know that we've reached the end of a list? Correct. So while, actually I might just close this top window. Oops. So while current is not equal to null and current data. So what am I going to do with that? What's in data? Well, okay, ID looks good. Okay. Is current data ID is less than ID. Yeah? Why am I doing less than? Because if you remember, if we go back up here, we inserted in sorted order. So I'm applying an optimization, and that is that if I get to an item and it is later in the sort order than the item I'm searching for, then the item isn't there. So on average, I only have to search over half the list, which is still going to be really slow, but it's better than having to search over the whole list. Okay, so what am I doing in this loop here? Yep, so prav equals current, learn to spell, and current equals current, next. Now something important to realize on line 67, right? That's a bit different to our comparison up here. How's it different? Well, it's important to realize that when it's not integer data, the best thing to do is to implement some kind of a comparison function to actually do the comparison, so that simplifies our code. And we will see next week the real power. Actually, no, we'll see in week 11 the real power of the comparison functions when we start to deal with generic data and generic types. But generally speaking, if you are doing a comparison over things which aren't comparable, so persons, etc., we should write a function which makes them comparable. Just like in the standard library they do it with strcomp, so that we have a comparison over strings. Here I've got a comparison over persons. Okay. Right here. So we get to the end of this loop. What are the possible things which might be the case? Right. So if not prev, or prev is null, same thing. What do we do? Well, we need to... Actually, probably what's a good idea here is... Yeah. So what we would do is set list head to be equal to list head next. Well, actually, let's think about this. Correct. Because the item might be earlier in the sort order but still not in the list. Good point. So if current data ID is not equal to ID. So we'll deal with it as, well, what I would do is deal with it as an error condition. Yeah. So once again, we print out just standard error item not found. Okay. Then we can there's something like we do need to free the memory But what I'm going to do is I'm going to do that at the end. So I only have to call that code once. Yes, good point, actually, because otherwise I'm going to have this same code repeated. So if you press D in Vim, when you've got some code selected, it deletes it and cuts it. So I can now press P to paste it. P to paste it. Okay. Now I can tell Vim to automatically format my code. GG takes me to the top, equals, and capital G. So now if I go back down there, you see, oh, where did, hang on. I'm in the wrong place. Yep. There's a problem. Yeah, there is a point beyond which when you start to customize things where you cease to be able to actually use the original program. I don't know. Yeah. Anyway. So, but there's a problem on this line, isn't there? There's a bug. The bug is that current might be null. Yep. So in fact what we can do, because if current is null, this is also true. Yeah. So if current is null, or the current data ID is not the ID, then they both represent failed searches. No. All we do up here is check the list as empty. That provides no guarantee on what's actually in the list. Yeah. No, because you haven't, you need to iterate over the list to find the item. So we don't know, well, you know, we don't know how far along the list the item we want to delete will be. Correct. Okay. Do we need to specifically... So, if we've dealt with current being null, we've dealt with previous being null. So, there's only one other situation, isn't there? Yeah, when we're somewhere in the middle of the list. So, in that case, all we need to do is we need to set previous as... Now, might actually... oh yeah. Use dia. So I might just drag that across. So we've got this situation where we have... Okay, let's just pretend these are list nodes because I can't draw to save my life. Yep. And we've got essentially this kind of thing happening. Right? And what we want to do is we want to remove this middle item. So all we really need to do is take the arrow and point it to that other item, because now it just falls out. Does that make sense? That's what list deletion looks like. And then we've got to free it, absolutely. But that's the idea. And it doesn't matter that this one still points to there because it's going to be irrelevant. Okay, so now that means in code previous, this is next, equals the current. So will this work if current is the last item in the list? Yep. It will work for anywhere except if current was actually at the head. And that's why we have to deal with the head separately. Right? So, we now need to free our data. Is it okay for us to just do free current? Will that work? Why not? Correct. So whatever has been returned from malloc must be passed to free. So if we go up the top here, the thing is that we assumed from the get-go was that this was mallocked, that the person was mallocked, and in fact, oops, it was allocated with this make person, and therefore it must also be freed. Now what we might do is actually make a person free function up in the person library, but in this case person doesn't have, like, it's all a single chunk, right? There's no, person doesn't have any pointers inside itself, so we can just free the data in one block because it was allocated in one block. So therefore, going down here, we free current data. And don't forget to decrement your number of nodes. Okay, so that's delete. So let's have a, are there any issues or concerns with our delete code? Anything you're not sure about, you'd like more explanation? Okay, so let's talk about the list free function. So what we'll do is, once again, I might make one called next this time, because that's kind of what it's going to be. It's going to be pointed to the next item. Okay. So all of this should be familiar by now. It's all list iteration. So what should we do to actually free the data? How are we going to go about this? Yep, so while char okay, is this okay to do? Note, because now I am accessing freed data. Right? So what I actually should do is set next to be current next. Yep. Then don't forget to free the data, so free we have to free the data before we free current itself. And then current equals next. Yep. So that's essentially it. Now technically I probably should decrement the count, but at this point, or the num nodes, but at this point it's not going to be used, where the whole point is to actually free the entire structure. Therefore we can assume that we can do away with the decrementing here, because it's not going to be used. It has no point. It just occupies additional instructions. Okay, so there's that. So let's go back to our main.c. So now we've pretty much got a complete program. Well, you've got to fill in the fgetS code up here, but otherwise it's complete. So the question is, I want to be able to easily compile this multi-file program. How can I do that? So I don't have to type all that GCC, ANSI wall pedantic, etc, etc, etc all the time. Correct, a makefile. So let's create a makefile. So the GNU standard states that a makefile should start with a capital M. Now you can have a lowercase m, but it's not as correct. So let's just, touch allows me to create a 0 length file. Okay, I'll open this in Emacs because I have my Vim set up so that it turns all tabs into spaces. So I rather than me mucking around with my config there, I'll use this program here. So I like to, let's start with, well, I like to have some variables in my, you don't have to use these, but I kind of find it's cool, it's useful, you know, doing things like, say, the sources for my program. Well, that's all the lists, that's all the .c files. So we've got list.c, person.c, yep. We've also got main.c. Also got some headers being list.h, person.h. I think that's all of them. Bool.h. So we'll add that. So one of the things about the way a C compiler works is that it compiles each C file separately, right? And so why do you think we want to do that? let's think about a program like GCC itself. Last time I tried to compile GCC from source, and yes, you can do that. It had over 29,000 C files. Now, yeah. So, who wants to compile that from scratch every time? Anybody? I can tell you that it took me about 6 hours. Well, it didn't take me 6 hours. It took my computer 6 hours. And the reason why is I wanted to use the latest and the greatest, and it didn't come as a package that I could just install. I needed to compile from scratch. Well, probably on Titan it would take less time, because actually Titan's pretty powerful. It's got 40 CPUs, whereas the machine I compiled it on had maybe 4 CPUs. And each of those CPUs on the machine I compiled it on was far less powerful than each CPU on Titan. Right? So, yeah. You don't have enough space in your home directory to do it. It takes about 8 gigs of space to compile GCC because of all the extra files it generates and so on. But anyway, that's beside the point. The point is, I don't want to compile it from scratch each time. If, for example, I am a GCC developer, or probably a even better one would be if I am a Linux kernel developer, which is bigger actually than GCC, then I don't want to have to compile the Linux kernel from scratch every time I compile it. Say, for example, I change 2 lines of code. I don't want that to take me 6 hours to do. That sounds fair enough? So, what we do is we specify prerequisites and we specify targets, and we can specify other targets to be prerequisites for this target. Okay? So let's do that. So we're going to also let's have some standard variables which will make your life easier. If you specify in your makefile what compiler you're going to use, and we'll specify a couple of other variables as well, it will make your life easier. So CC means the C compiler, C flags, so compiler flags. Let's make that ANSI wall pedantic. And LD or linker flags. Linker flags are flags which you need to bring in an external library. So what I might do, for example, is minus lm. Now that links in the math library, which you might need in particular situations. Aha, thank you, Paul. I'll actually specify here that if you are going to compile with minus g, you'll put that up here in the C flags. But I'll show you a better way in just a moment. The way, in fact, that you will see if you look back at your debugging exercise, that I did that for you there. Okay, so let's say what's common is to have a target up the top called all, which actually lists the things to be debugged, to be compiled. So in this case, we've got something called person list, right? Which is actually, and the first target, the one right up the top here, is the default. So if I just type make, so let me show you that, in fact. Rightio. So if I just type make, what's going on there? Aha! Let me just right. So now what this says is that in order to make all, person list is a prereq, is a requirement. Now in order to make person list, I have specified no prerequisites here. And it says, hello, I will make a person list. Okay. That's kind of like the hello world of makefiles. But anyway. So now, what I want to do is specify the prerequisites for the makefile. And so, let me just actually add another one up here. That's called objects. Now objects are the things we create. So that's list.o, person.o, and main.o. Now what you could do, in fact, is write down here list.o. Okay, list.o. Now I'm just, well, obviously list.o needs list.c because it's the .c file which we are compiling. And what I could do is then go list.h, person.h, bool.h, right? And then I'm showing you here what would be required in order to get the marks for makefiles, but not necessarily have a good makefile. Okay, so we're going to compile only. So it's important to realize what happens, do you think, if I type gcc star.c minus o list. Okay, there's some errors there, but Okay, I've missed out on some. Oh, let me just deal with that. So the issue it's complaining about is up the top here. I haven't actually included important things. I've got send a lib. Ah. Yes, good point. Okay, still some problems. Yeah, that's in. So let's. Okay, let's see. Okay, that's a bit better. Okay, need brackets there. I always kind of forget when I need or don't need brackets. But generally for types you need brackets, whereas for variables you don't. But anyway. Okay. Okay. This will be easy, this bit. And what? 36. Huh. Oh, I'm not going to worry. Yeah. Oh, yeah. Oh, yeah. Include guard. So, do people understand what this bit of code does? Hash if ndef person h. Correct. And it's because of the fact that each .c file includes multiple .h files which may include each other. So, yeah. Aha. I did it there too. That's weird. Okay, yep, list print is not defined. That's fine. But okay, now the question is though, when I do that, what happens? What are the phases which go on when I do that? When I compile all the dots, when I say gcc star.c minus o list, what's that? What's the compiler go off and do? That matters for our discussion of makefiles. For example, the very first phase is when the C preprocessor is called. People remember what the C preprocessor does? Yeah. William has listed the things there. So if I do GCC minus E, although the order is around a little bit not quite right, but yeah, GCC minus E says stop processing once you have replaced all the pre-compiler directives. So in this case, you noticed with bool.h, well, there's nothing there. Well, there is a this wrapper to prevent it being included multiple times. That's all. And so, because it's the first time, yeah, okay, this is what it resolves to. But what about GCC minus E on list.h? Oh, seemed like a few things going on there. We got things from standard.io.h, standard lib, and all kinds of stuff going on here. So what's going on then is that the hash include is literal. Yeah? It literally includes the text from all of the files you've asked for. And that's why all of this literally gets included in my list.h. All of these function prototypes and so on, so that I can actually call them if I want. That's how that works. And it goes on for quite a while. In fact, if I did this and I piped it into WC, which does a word count, and specify count how many lines, that list.h, which is 23 lines long, actually becomes over 2,000 lines long because of all of the hash includes. Right, so that's okay. There's that. Now, there's also, if I did GCC minus S on list.c, it might be capital S actually. Audio. So this is the assembly language instructions defined by list.c. Right? And if I was wanting to kind of figure out what was going on, if there was some issue with the way the compiler was behaving, I could actually go through and read through this assembler code and actually debug it and so on. Okay, but generally we don't want to stop at either of those two phases. What we want to do is we want to stop at the compilation phase. Right, so we want to stop when we have compiled units. So GCC, so if we go back, that's what the minus C means. So don't link. Right? So the linking phase, so if I do something like GCC minus C list.c, I've got this list.o file, which if I open that up, it's actually just a binary file with the strings and library and references to libraries and so various objects which are used in my program, like PERA and malloc and so on and so forth. So it is references to the things that I use and the binary code for my program. So why on earth am I getting you to, why am I explaining that? Well, if we go back to what we're doing is when we compile each file, we're going to stop at the end of compilation. Right? You see how this in fact, oops, there is a mistake here. But yeah, so this will compile list.c to a binary object file, but not a linked program. Right? So when you have that project with 10,000 plus source files and you make one change, it only recompiles that one file. Unless the file you changed was a header file. So in this case, if you modified list.h, person.h, or bool.h, you would force the recompilation of this target. Does everyone see that? That if you changed list.c, list.h, person.h, or bool.h, you would actually force the recompilation of this target. I've noticed a couple of people leaving. I really advise you not to at this point because this is important stuff. Of course, people who have left won't have heard that. So, yeah, anyway. But does that make sense? I need some feedback, guys. I'm not getting any feedback. Well, because, for example, well, let's look concretely at what's in the header file, okay? Yep. So if we look at person.h, okay? So if I change the definition of the struct person, that changes the size of a person struct. So for example, if I add now person is 4 bytes longer, and so the entire memory layout of the program can be changed by this. Yeah. And I have here specified the function prototypes, which will be implemented elsewhere. So if the prototype is changed here, then it needs to be consistent with all other calls. That kind of stuff. Okay, so what I've got so far is so you see, can you see how you could use this pattern for every object file that you create? So you could do, for example, okay, I also need to make person.o, and person.o really needs person.c and person.h. I don't think it depends on anything else. Right? And then I could have GCC and then for completion, main.o just needs main.c. Well, it actually needs all of the header files, so list.h, person.h, and bool.h. Right? So that would be fine. And so we had a clean target, and it's normal to declare that clean is phony, and what it means is that clean doesn't create any files. Pednatic. So this is also a reason for the more advanced version that I'm about to show you. So clean is a phony in that it doesn't create files. It doesn't make something. That's the point about make, is that in fact it makes things. So what we would do is rm-f star.o and person list. So they are the files which are being created as part of compilation, and so you now have a clean target which deletes those files so that you only have the files that you need for submission. Okay, now the only thing we have left to do is in fact, so person list, what prerequisites does person list have then? What things have to be made in order for me to link this together into a complete program? Right, so list.o, person.o. Yes, good. Well, actually, I'm going to use that very point in just a moment, Paul, to actually make this simpler. main.o. Now, think about those flags: ANSI, wall, pedantic. Do you think they're required by the linker? The linker, remember, we have all the global objects which get linked together into a final executable. So global objects include things like function calls, global variables, etc. No, we don't. So GCC list.o, person.o, main.o, minus o, person list, right? So this, in fact, now the complication you have in your assignment is, in fact, you have two targets. You have a reversely linked and a reversely array, and they will need to call clean before build. Correct. Yes. So in fact, let's actually clean this up and actually see how much we can cut this down so we have a much smaller file. So let's start with these objects up the top and go, yeah, I need the objects. Much better. Then I can, in fact, I prefer to use that same variable here. Now there's something I haven't told you yet, and that is that in between the left margin and the first thing typed as part of a target, there must be a tab character. It must be a tab, cannot be spaces. It will not work with spaces. It must be a tab. Okay? We can even make this smaller, in fact, by using a special variable $at, and it says use the name of the target. Yes, good, 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 good. That's the next thing to do. Right. So I'm going to actually make this even simpler now. Instead of using this list.o, personal.o, main.o, what I'm going to say is I'm going to use a special makefile wildcard. Remember, what I have now is valid, but what I'm going to write is much cheaper, is less work. So we have a whole bunch of object files, %.o, so match anything before .o, right? Now that will match a particular .c file. So that's then we specify the C flags minus C $arrow. That is the first dependency. So now, all this other stuff here, I don't need it anymore. So that's a complete make file for this project. But there is something else I want to do. Let's say I want to create a debug target. That is, I want to actually have a version of the program which compiles. I forgot one thing actually. And that's at the end here. I need the LD flags for the linker. So, but what if I want to have a version of the program which I run with GDB and a version which I release to you? Can I do that using my makefile? Well, yes, we can. What we can do is I can define something called debug, which I'll actually have a variable here, cflags, but I'm going to add to my cflags plus equals minus g. And debug depends upon clean and all. And that's it. So what it means is that as part of the debug, it will call clean, which will delete all the files, and then it will add minus G onto cflags and recompile the program. So this is a sophisticated makefile, and in fact you only have to make a couple of changes really to get it working with your program, working with the two different types of lists. So, any questions about that? So you can see makefiles are really powerful, and you can see the way I've written this makefile. You only need to make a few changes. This is it's reasonably sophisticated. But it's a way you would really write one. The way I had this originally is acceptable. Yeah, it's a very simple, well, you know, if you compare make with, say, Ant, which is used for Java, Ant is a lot more, I find it's a lot more complicated, a lot more verbose, but and most things which you can actually type in the shell, you can actually put in a makefile. It was meant to be a generic way to build things, specifically C programs, but you could use it for anything. Anything which requires you to make something. So you have your prerequisites, you have your targets, you have your prerequisites. And it basically automatically finds the right things to rebuild. And it does it based on modification dates. So it compares the modification date of the last binary compiled with the modification date of the prereqs. You can, but sometimes I might have an additional .c file that is not part of this project. Yes, you can actually write scripts which actually find what all of the C files are going to be compiled are. You know, using like shell scripts and that kind of thing, find under here all the .c files and put them in this variable. With the, yeah. So I might leave that there. You've got pretty much everything you need for your assignment now. We will go through it on no. The important thing for me is that you are building the object file separately and then linking. That is a requirement. What I would also do is so I'd have debug, maybe have a look at something like a debug or a sanitize target. Have a look at my make files from the debugging assessment. They can give you an idea about how to do these as well. I don't actually mind if you use them as a starting point and then edit, because you have to understand the file enough to be able to edit it. Obviously, if you base something on something I've given you, probably put some kind of thing in the README file about, because it is the right thing to credit other people for their contribution to your work. Control C. So Control X S saves, Control X C exits. No, I just think that when people contribute to your work, they should be acknowledged. I tend to, it's like the Unix Survival Guide, which I maintain. I actually have credits in there of people who've previously worked on it. So what I might do is CP minus R person list. Let's just CD up one, CP minus R person list. And we're going to throw it into shared week. Actually, there might be one already in. I'll throw it in week 8 to 9. So now if I CD into shared tutes week 8 to 9, and we go into person list, there it is. And what I might do is and move start.c start.h into old. So that makes it a bit clearer. Yep, so you can read those files. Cool. Yeah, I do kind of give you a lot, but there's lots of things for you to actually piece together as well. So it's not, there's a lot of there that you got to figure out yourself as well. So I try to strike a balance. Oh, really? Okay, what I'll do, chmod 755 star. Try now. Yep, no worries. Cool. Okay, so I'll see you on Wednesday if you're coming to my Q&A on assignment 2. Good luck. No worries. Cool.